Alright, we're going to look at some tessellation questions in this video clip. Tessellation, the maths that you need to be able to recall is angles around a point. You need to know that angles around a point add up to 360 degrees. And by around a point, I mean if you've got angles like that, then the sum of those angles must add up to 360 degrees. You also need to know how to work out the interior and exterior angle of polygons. So if you've got a regular six-sided polygon, the exterior angle, which is these ones, or which are these ones, turn completely around a point. If you walk that path, you will have turned through 360 degrees and you would have turned 6 times. So the exterior angle is 360 divided by the number of sides. And then once you know what the exterior angle is, the interior angle, the exterior and the interior lie on a straight line. So you take the exterior away from 180, and it gives you what the interior is. Oops. So those are the math facts that you need to know, and in order for a shape or a combination of shapes to tessellate, it means that they will completely fit together around a point, so the sum of their angles is going to be 360 degrees. Okay, let's take a look at these questions. Ben needs to tile his kitchen floor and decides to use 2 types of tiles shown in the diagram. By drawing more tiles in the diagram, show that the tiles will tessellate. So we've just got to continue this pattern enough times to show that it will completely cover the space and there won't be any gaps. So if you see here, we could put a square tile there and then one of these hexagonal tiles there and there and there, and then if we put another square tile there, we can see that we've completely surrounded that square in the middle. So that pattern we could continue to grow right across the grid, but we've drawn enough tiles there. 1, 2, 3, 4, 5. Actually it wants at least 6 for the 2 marks, so let's draw another couple of those in to see how that shape is continuing. So there's 2 marks for that, 1 mark for at least 3 shapes, the second mark for at least 6 shapes. Question 2. Maggie has lots of tiles. All of her tiles are in the shape of regular polygons. The edges of all the tiles have the same length. She places 2 12-sided tiles to meet edge to edge. Maggie places a different shaped tile with these 2 tiles. She finds that the 3 tiles tessellate. By calculation, find the number of sides in this 3rd tile. So in order to do that, we need to know what the internal angles are of this 12-sided shape. So for the 12-sided shape, 2 stages. First of all, find the exterior angle. And that would be 360 divided by 12. Well, 12 goes into 36 3 times. So that would be 30 degrees. So that means the interior angle will be 180 less 30 equals 50 degrees. So if we draw part of this 12-sided shape, I'm not going to draw a completely 12-sided shape, 150 degrees is going to look something like that. So she's going to fit two of those together. So if that's 150 degrees, the next shape is going to be similarly 150 degrees. So if they were to tessellate, that 150 and that 150 add up to 300, meaning this angle must be 60 degrees. So third shape must have an interior angle of 360 less 150 less 150, which is 60 degrees. Now hopefully you will recognize that a regular shape which has got a 60 degree interior angle is in fact an equilateral triangle. All the sides are the same length and all the angles are the same, which is 180 degrees. So that's what they're looking for you to do there, is to recognize that that's going to give you an equilateral triangle. So the marks for that, there's one mark for working out the exterior angle, one mark for working out the interior angle. There's a method mark and an answer mark for getting to 60 and explaining that that's the difference between 300 and 360. And then there's a final mark for recognizing that the regular polygon with 60 degree interior angle is the equilateral triangle. Question 3. Ali has a number of tiles. He has some square tiles and some tiles in the shape of equilateral triangles. The edges of all the tiles are of equal length. He uses some tiles of each shape to make an example of a tessellation. Sketch how Ali can use square tiles and tiles in the shape of equilateral triangles to make an example of a tessellation. Explain, using your knowledge of angle facts, why this is an example of a tessellation. You must include at least one tile of each shape and show all your calculations. Okay, so square tiles, let's just draw a little sketch. We know I've got interior angles of 90 degrees, and equilateral triangles, as we reminded ourselves in the previous question, their interior angles all add up to 60. So in order for those to tessellate, I have to find a combination of 90s and 60s that will add up to give 360. Now I know that two 90s are 180, and I also know that three 60s are 180. So I should be able to get a tessellation if I have two squares and three equilateral triangles, because that comes to 180 and that comes to 180. So it should tessellate with two squares and three triangles. So it's asking us to sketch that. So if I sketch a square, and coming off that a right angled, a 60-degree equilateral triangle. And then if I have another square, and then another equilateral triangle, I'm going to end up with another equilateral triangle in there. So the angle around the point, explain using your knowledge of angle facts. Angles around a point add to 360 degrees. So 60 plus 60 plus 60 plus 90 plus 90 is 180 plus 180, which is 360. So that's what they're looking for you to do. How many marks for that? 4. So there's 2 marks for showing how that will come together. So you sketch 1 mark for stating that angles around a point add up to 360, and 1 mark for showing that our angles around that point actually add up to 360. Question 4. So this is a QWC question, or OCW as they're now known, where you're going to be credited 2 marks for how you organise and explain your work. So the pattern below is made using small square tiles and octagonal tiles. Is it possible to use this pattern of tiles to tessellate and completely cover a rectangular area with only the need to cut the tiles at the edges of the rectangle? So basically, can you continue that shape without any gaps apart from on the sides of the rectangle? We can pretty much see just by looking at it that the case is yes, because we could have another octagon there and another octagon there, and then we'd have a square there and a square there. So we can see by sketching, but we have to show that that's actually true. So if we explain that now, in order to tessellate, interior angles of an octagon and square must add to 360. So the interior angle of that we know. Interior angle of square is 90. So for the octagon, first of all, exterior angle is going to be 360 divided by number of sides. An octagon is 8. So we do 360 divided by 8, 45 degrees. So the interior of octagon is 180 less 45, which is 135 degrees. So if you look around this point now, we've got 135 there, 90, 135. So for shapes to tessellate, 135 plus 135 plus 90 must equal 360. 135 and 135 is 270 plus 90, which does equal 360. So that's true, therefore shapes tessellate. So in order to get those communication marks, you're not writing a story, you're not writing an essay, you're just explaining what you're doing. So I've extended the diagram slightly to see that it's fairly obvious up there. In order to tessellate, the interior angle of the octagon and the square must add to 360, and we're showing that there. We know the interior angle of a square is 90, you don't have to mathematically prove that. So for the octagon, we can find the exterior angle, 360 divided by the number of sides is 8, from that the interior. Once I've got the interior, I can see there from that shape, from my sketch, that I've got two interior angles of the octagon and one interior angle of the square. So if I add those three together and they give me 360, the shape will tessellate. So there's 8 marks for that. So let's see where those are awarded. So there's 1 mark for the 90 degrees for the square. There's a method mark for doing 360 divided by 8, and an answer mark for getting 45. And then there's an answer mark for working out the interior angle being 135. Then there's a mark for then showing that the sum of those is 360, and an explanation mark for basically either saying what you're saying up there, that they must add up to 360, or your conclusion there. And then the additional 2 are for the way that you lay that out in an organised and clear fashion. So plus 2 for that. Okay, well 5A isn't a tessellation question, that's a parallel line angle property question, so we'll skip that. 5B is the tessellation. So the tile shown is a rhombus. Explain why tiles identical to the one shown tessellate. You must give reasons for your answer. Well, in a rhombus, it's quadrilateral, so all the internal angles must add up to 360 degrees, but also the opposite angles are equal to. So if that's 140, so is that. And if that's the case, those add up to 280. So these two are going to be 360, so the smaller angles in rhombus will be 360 minus 140 minus 140, which is 360 minus 280, which is 80 degrees, divided by 2, because that's both of them. Okay, you could have just written it down, you could have worked it out in your head, you could have just written it in there, it doesn't matter. They're looking for site of the 40 degrees. So if this is going to tessellate, what's going to happen is we're going to have another 140 there, and then this up here is going to be another one of them, which will make that 40, and down there that would be 40. So for it to tessellate, sum of those angles must equal 360. So sum of internal angles must add to 360. So we've got 140 plus 40 plus 140 plus 40, which is 180 plus 180 equals 360. So they're going to tessellate. Marks for that. 1 mark for site of 40, so wherever it appears. 1 mark for showing that the sum of those is 180. And 1 mark for angles around a point, sum of the angles equals 360. So there you go, there's some examples of tessellation questions.